So here we have a question about a shape made from smaller triangles. We're given some details about the triangles. 5 of these triangles are put together to make this shape, and we're asked about the perimeter of the shape. This has come up a few times in different forms. There's a trick to it, which I will show you, but make sure you get it right as to whether you want the area or the perimeter, otherwise you're going to kick yourself afterwards. This is a right-angled triangle, so we're straight in with the focus SOHCAHTOA and of course Pythagoras, which brings up all of our lovely brain thoughts about right-angled triangles, sines, coses, tans. There's even an area snuck in here, we won't be using that. And our old friend Pythagoras. We're going to try and label up this triangle. This is the opposite of the 72-degree angle. This is the adjacent. That's a hypothesis, the hypotenuse. Let's work out the adjacent using opposite over adjacent, which is tan of 72. Tan x equals opposite over adjacent. We want to get the adjacent, so we need the adjacent on its own. So we'll multiply by the adjacent. We've got adjacent times tan 72 equals opposite. Divide by tan 72. Adjacent equals the opposite, which is 12.8, divided by tan 72 equals 12.8 divided by 3.0777 apparently, which as we all know equals 4.1590. I don't mind having lots of decimal places here. I'm not going to try and think about how many I should have in order to get 3 significant figures. Let's just write them all down, or write a few of them down, because it stays in the calculator. Anyway, we've now got adjacent and the opposite. We'll use my old mate Pythagoras to get the hypotenuse, x squared plus y squared, or in this case hypotenuse equals 12.8 times our new adjacent 4.159 equals 181. I am sure you will not forget to take the square root of 181 to find the hypotenuse. 13.4587. Is it reasonable? 12, 13 and 4 and a bit? Yeah, it's quite reasonable. But I'm going to check anyway, and there's a surprise at the end of this question, which I won't ruin. But there's an easy check. We've used the Pythagoras to find the hypotenuse. Let's see if sine works. Sine, of course, being opposite over hypotenuse, opposite over hypotenuse. 12.8 over our recently discovered hypotenuse is 0.951, which incidentally is sine of 72 degrees. So I feel warm and cuddly now because I think I've bagged these extra lengths. Now we'll move on to looking at the shape. There's a trick to the shape. This is obviously the opposite because it's the long side with the right angle. This length here is obviously the hypotenuse, and this little one is the adjacent. So we can work out what this is. We're looking at the perimeter. It's not an obvious length, but it's the hypotenuse minus the adjacent. And this is true of almost all the mosaics I've looked at, is that one of these sides is going to be one of the sides of the little chip or triangle in this case, less at a smaller side. So we have an hypotenuse and we have length L, which I've called L for length, and we should be able to say that L equals hypotenuse minus the adjacent. It's the hypotenuse minus the adjacent, and we can work it out to be roughly 9.3. Which, I mean, again, this is not drawn to scale, but you can see that's probably not unrealistic. So we need to go around the perimeter and sum these up. Well, this is just one triangle, has an opposite and a length in its perimeter. There's 5 of them, so surprise, surprise, perimeter equals 5L plus 5 opposites. 5 times our length L and 5 times our opposite, 12.8, 110.4986. A miserable number, really. Very close to being rounded up to 111, but I've checked it. It's right. 3 significant figures will be 110. Thank you very much. Quite a nice little question, really. important to know the trick, otherwise you'll be in trouble. But it's also a scavenger's heaven, because you will get a mark just for getting out what the adjacent is, or the hypotenuse, but we went for the adjacent. And if you actually calculate it correctly, you'll get a second mark. And if you get the third length, or the second length, you'll get a third mark. 3 marks out of 5 just for getting the lengths that you haven't got in this shape. If you were given this shape and asked to find the 2 missing lengths for 3 marks, you'd be very happy indeed, particularly this late. So we've checked it, it's good. You need to get the formula for the perimeter, 5L plus 5 opposites, for the 4th mark, and you need to get it out for the 5th mark. This is probably the hardest one. If you don't know the trick, you might be in trouble. And some people will look at this question and go, I don't know what's going on here with this shape, and might not even try and get the easy marks which are on offer, just finding the additional lengths. So let's think about the takeaways, because always try and remember and learn something from these questions. Takeaway: scavenging is good and it earns good marks. Check before going too far, because you want to pick up your scavenging marks, and had you made a small and easily made mistake, you'd have spotted it here and you could have gone back and got those 3 marks. And finally, mosaics have this trick that one of the lengths of a shape is going to be a long length minus a short length. Just make sure you get the lengths right. Enjoy. Now, I suggest you look at this for a while and maybe try it yourself.